This is worksheet 29.1 review. Let's look at number 35. At a local advertising firm, the average starting salary for an employee with a bachelor's degree is $45,000, and the standard deviation is 6250. The distribution is approximately normal. What percent of employees earns a starting salary of, in this problem, of at least $62,000? First thing we want to do is look at this value, the $62,000, and what we're being asked is, if you're looking at the normal model, how many, as a percentage, what percentage of employees earn $62,000 or more? That's what the at least is referring to. So before I can figure out the percentage that earns $62,000 or more, I need to figure out what that z-score would be that goes with $62,000. So here, the z-score, again, z-score represents the number of standard deviations away from the mean. So 62,000 minus the average of 45,000 divided by the standard deviation. So here we get a z-score of 2.72. Now, in order to find the percent, we need to look this up in our z-table. 2.72 would be over here. 2.72 gives us 99.67%. But remember that the z-table will always give you the percent less than the value that you looked up. So since this is asking for how much of the employees earned at least $62,000, we're just going to take 100% minus the 99.67% that we just looked up in the table. And if we do that, 100 minus 99.67, we get 0.33% of employees. Now on number 36, it's another stats question here. Green's Organic Market has a surplus of onions, and in the most recent onion delivery, the size of the onions was normally distributed. The average circumference was 11 inches, the standard deviation was 0.75 inches, and the manager decided that if an onion circumference is not in the 40th percentile or higher, it would be given away for free. What is the circumference of the largest onion that would be given away? Now in this case, we know the percentile of the onion. Now if we're looking up a percentile in our z-table, the only way we'd be able to calculate the circumference of the onion is to figure out what the onion's z-score is. So in our table, we're going to look for 0.4, get as close as you can. So here we have 0.3974 or 0.4013. 0.4013 is a little bit closer, so negative 0.25 is our z-score. And using that z-score, now we can calculate how big the onion was. That is the largest onion that would be given away. So x minus the mean divided by the standard deviation. Now solving this equation, we need to multiply negative 0.25 times 0.75 and then add 11. Okay, so this would be 10.81 inches, which is the size of the largest onion.